So what do you think I should do here? Can we go back to where it's an exponential? So what would happen with this 2? Okay, so this is log base 5 of x squared equals log base 5 of 9. Yesterday we said it was legal to add a log to each side, so today what do you think I'm going to do? Take it away. So x squared equals 9. Okay, to get rid of a square, square root, plus or minus, so you get x to equal positive or negative 3. However, you need to check these answers. When we started talking about logs, I told you that the domain of a log was always positive. You cannot do the log of a negative number. And I think you got that issue on one of your homework questions. There was a problem where it was like 1/3 to the x equals negative 3. And you tried to add a log to each side, and what happened when you put that in your calculator? It said domain error, because you can't do the log of a negative. So what was the solution for that? No solution. So here, when I'm looking at this, we need to check and make sure that when I plug these in, my argument is positive. So is it okay to put a 3 here? Yes. Is it okay to put a negative 3 there? No. So you're checking that the argument is positive at the end. So my only answer here is 3. So because the original problem started with logs, we have to check the domain on this. All right. Look at this one. So what would we do here? All right, turn them into exponents. So we have log base 2 of x to the 3rd. What would I do with this negative? That's 27 to the negative 1 power, or that can be written as 1/27. Now we have a single log on each side, so we can drop that log. So x cubed equals 1/27. How do we get rid of a cube? Do you have to put a plus or minus? Only if the index is even. So if it's a square root, a fourth root, you add plus or minus. With the odds, you do not, because you can do negatives. So the cube root of 1 is 1, cube root of 27 is 3. Quick check, if I plug that back in, is my argument positive? Yes, so my answer is 1. All right, are we up for more of a challenge? Okay, here we go. Logs are added, what do we do with them? So, I have to take x plus 6 times x plus 2, so I'm going to FOIL that. X squared plus 2x plus 6x, so that's plus 8x plus 12. So what I did, just in case you need me to show my work, we can combine by multiplying those arguments. Okay, this is different though. We know we can add a log to each side. We can take it away from both sides. We can't add it to only one side. Do you guys remember at the very beginning when we went back and forth between log and exponential equations? And we said the base of the log is the base of the exponential. So this means 5 to the first power squared plus 8x plus 12. Okay. Now what would I do? Subtract our 5 over. And we can factor. Multiply the 7 and add to 8. So if we set those equal to 0, we get x to be -7 and -1. Am I done? We have to check. So I am putting these back into the original, and all you have to verify is that they're positive. Okay, is -7 plus 6 positive? Nope, so it's out. Is -1 plus 6 positive? Yes. Is -1 plus 2 positive? Yes, so that one is okay. So -1 is my only answer. Okay. Why don't you guys try one of those? So 2 logs added, we put them together with multiplication, which means you have to FOIL. So we get log base 2 of x squared plus 15x plus 56. Since there's already a log on one side, but not the other, we can't just take it away, so we have to do the definition of a log. So that means 2 to the first power equals x squared plus 15x plus 56. 2 to the first is 2, so subtract that over. What multiplies to 54 and adds to 15? Set those to 0 and we get -9, -6. But we check. -9 plus 7 is not positive, so that's out. -6 plus 7 is good, -6 plus 8 is good, so -6 is the solution. All right, how about this problem? All right, what would I do with the 3? Now, if 2 logs are divided, how do we put them together? Or sorry, 2 logs are subtracted, how do we put them together? Oh, good job, guys. Okay, it's only a log on one side, so what do we have to do? The 5th power is x minus 1 cubed over 4. Okay, 2 to the 5th, that's 32. So now what? So I get 128 equals x minus 1 cubed. Alright, so then we have to do the cube root. It doesn't work out perfectly. That's okay because remember yesterday we were putting these in the calculator and getting decimal answers. So they don't all have to be nice, pretty numbers. What would be the final step to get x by itself? Add 1. So I'm going to type in the cube root of 128 plus 1. Again, because it was an odd root, we don't have to have plus or minus, but if it was a square root, we would. However, what do we need to remember to do here? have to check it. So if I plug that back in, I'm just verifying that my arguments are positive. So 6 point something minus 1 is positive. We're good. Is that okay? Okay. Can I combine 1 plus the log of x minus 2? No. What did you say, Joan? Both of these terms have a log, so let's get them on the same side. So we have the log of 2x plus 1 minus the log of x minus 2. So now these logs are subtracted, which means we can combine them by division. Okay, if I don't have a base on my log, what is it? This means 10 to the first equals 2x plus 1 over x minus 2. Right, 10 to the first is just 10, so we can multiply over the x minus 2. So if we distribute, we get 10x minus 20 equals 2x plus 1. Subtract over the 2x, add over the 20, divide, and x is 21 over 8. Check. When we plug that in, my argument's positive. So you can certainly convert that into a decimal if you want. It's like 16.3875. Okay, so when we plug that in, are my arguments positive? Yes. So we're good. You guys want to try it on your own? Let's see how far you can go. If our logs are being subtracted, how do we put them together? Division. So that's x squared plus x divided by x squared minus x. Then we use the definition. So that means 1/3 to the negative 1 power equals x squared plus x over x squared minus. What is 1/3 to the negative 1? So then we can multiply over the denominator. So we get 3x squared minus 3x equals x squared plus x. Set it equal to 0. So if I subtract over my x squared, subtract my x, all right, what can we factor out? or positive 2. But what do we have to do? Check them. So when I put in a 0, 0 squared plus 0, it has to be a positive number. Is 0 positive? No, so 0 doesn't work. If I put in a 2, I get 6, and 4 minus 2 is 2, so 2 is okay. So 2 is my only answer. What if neither one worked? What would we say? No solution. And that is possible. So it doesn't, we don't always have an answer. All right. I have 2 more that I would like to do. What do you think we should do first? We can condense these logs. They are added together so we can multiply the argument. So x times x minus 4 equals x squared minus 4x. What do we have now? Yeah, we have 2 options. We can subtract over the log and divide them. What else could we do? We could, since we have 1 log on each side, we could drop the natural log. We'll get the same answer either way. If you have this, it's probably faster to just realize I have 1 log on each side, I can drop it. So then the arguments are equal. So we set it equal to 0, so if we subtract the x, subtract the 6. What multiplies to negative 6 and adds to negative 5? X equals 6 and negative 1. And then we check them. 6 is good, 6 minus 4 is good, 6 plus 6 is good. But negative 1 is not. So 6 is the only answer. That one okay? Last problem of the day. Let's save the best for last. That's not that bad. It's only a few logs. A few. You know the golden spiral is all right, thoughts?
Oh my gosh, you guys solved it.
Yeah, I mean, the rest of us might as well sit back. We got it. All right. 2 logs being subtracted. If they're subtracted, how do we combine them? So x minus 1 over x plus 6. So I combined my left-hand side. If I look at the right, 2 logs being subtracted, so we can divide them. X minus 2 over x plus 3. Now, since we have 1 log on each side, we can just drop it. can go ahead and FOIL this out, I just wanna show what I'm doing here. So now we FOIL 3x squared plus 3x and minus x, we plus 2x minus 3. This one will be x squared plus 6x and minus 2x, will be plus 4x minus 12. Now what? Subtract. Hey, I told you this problem's nice. If we subtract x squared, that cancels. Subtract over my 4x, add over my 3. So we have negative 2x equals negative 9. So x is 9 halves, or 4.5. And then we just have to check all of them, make sure every argument is positive. So 4.5 minus 1 is positive, 4.5 plus 6 is positive, minus 2 plus 3, all of those are positive. So that is my final answer. All right. Want you guys to practice now. So again, I'm giving odd problems. Answers are in the back of the book so you can check yourself, but you have to have work. So 21 through 51, odd. You guys have quite a bit of time right now to work and ask questions.